All the participants are, first of all, good morning to the second day of the FDP. Today we'll be having Professor R.D. Garg from Department of Civil Engineering, IIT Roorkee, as our first speaker. He'll be speaking on national, let's say, latest trends in geomatics engineering. Second speaker will be Professor Milap Punia from Center for the Study of Regional Development, School of Social Sciences from Jawaharlal Nehru University, New Delhi, basically JNU, New Delhi. Water, he'll be speaking on water resource sustainability. Our third speaker will be Professor Poonam Sharma. Ma'am is director from Center for Disaster Management Studies, Shahid Bhagat Singh College, University of Delhi. She'll be speaking on applications of geospatial technology in measuring the impact of built environment, built up areas on the environmental sustainabilities in urban areas. So for all the sessions, you are requested to switch on your mic only when the, let's say, speaker asks you. Otherwise, most of the time, like yesterday also it happened, somebody switched on his mic and the discussion was something else. So you all are requested to kindly keep your mic switched off. Thank you. Sir will be joining very soon.
गलत कर दिया उसने, लिखवा के लाओगे।
Good morning to all the participants again. Professor R.D. Garg, actually, he is on this GATE exam duty. So, sir is joining, sir is trying to join. He will join very soon.
And,
Okay, sir has already joined. Sir,
yeah.
Sir, very good morning, sir.
Yeah.
Sir, camera
Good morning.
setup,
Good morning.
camera setup is not proper, I feel.
I think, yeah.
Yes,
Okay.
sir.
Oh, I think some login name is changed from me.
Sir, what is the login name, sir?
I think it is coming as name of my niece. Arini. Yeah.
Arini. Sir, 1 minute, sir. 1 minute. Sir.
Yeah. Arini, I think it is name of my niece. She might have used it. I don't know.
Sir, you can change the name if you want.
Okay. Let me. Where shall I change? You.
Or let it remain. Let it remain there, sir.
Yeah, I think.
No worries.
Security participants mute. I don't know, like how she might have used it sometime.
Sir, right at the entry, you could have changed it.
Okay, maybe
Not
at the end, but rename. Yeah.
Sir, that's okay. That will work.
Okay, I could look at it. Yeah, I think now it has changed.
Yes, sir. Yes, sir. So, good morning to all the participants. Welcome to the day 2 of FDP on advanced applications of remote sensing and GIS. Welcome to our first speaker, Professor R.D. Garg. Sir is professor in Department of Civil Engineering at IIT Roorkee. Professor R.D. Garg is like he's B and ME and PhD from IIT Roorkee. He has about 27 years of experience in the field of geomatics at ISRO and IIT. His research interests are land surveying, satellite image processing, optical thermal microwave, and hyperspectral remote sensing, subsurface investigations using GPR, ground penetrating radar, GIS, GPS, UAV, Lidar. He has supervised more than 22 PhDs and have 57 PhDs, MTech thesis on his name. He has published more than 125 research papers in international and national refereed journal with high impact factors. He has one book on his name, 11 book chapters, and presented in more than 150 conferences in India and abroad. He is involved in a number of international and national research projects and consultancy work. Sir is associate editor of Journal of Indian Society of Remote Sensing. Sir is like that journal is almost 45 years old, prestigious journal of Springer. Sir has won prestigious Indian Society of Remote Sensing SPAC award in 2003. He has been conferred more than 5 best paper awards. He was awarded 15 months fellowship by the Netherlands government to pursue research work at ITC, the Netherlands. He has organized 28 international and national training courses and delivered expert lecture in different parts of country and abroad. He is fellow of IEI, IWRS and senior member of IACSIT Singapore and member of several other professional bodies. Sir has received National Geospatial Award in 2018 by Indian Society of Remote Sensing. Sir has received Uttarakhand Eminent Engineer Award in 2018 by Institute of Engineers India, Uttarakhand State Chapter. He has been confirmed Outstanding Teachers Award in 2012 by IIT Roorkee for excellence in teaching and research. Sir has also received this award in Excellence Award 2017 by Institute of Engineers India RLC. Right now, also I got information from Professor S.K. Ghosh that Sir is the main in charge of 2022 JEE award. So, sir, welcome, sir, and sir, over to you, sir.
Thank you, Dr. Manoj Pawar. And it is a pleasure to be with all of you, although it is online. So I think Dr. Pawar has already given a very long intro. Let me come to the discussion topic.
But thank you very much for accepting our request in this busy schedule of yours because you are
It's my
traveling.
pleasure. It is my pleasure. Actually, I was not aware that what will be my schedule. That's right.
Yes,
Okay.
sir.
So I just, are you all able to see my screen?
Sir, yes, sir, yes, sir.
Yeah, I've just started the PowerPoint. Yeah, I hope all of you are able to see.
Yes, sir, yes, sir.
Okay, so good morning again. Basically, we are here to know a few things regarding the geomatics engineering. What is new in geomatics engineering? So basically, you all know that geomatics engineering has got few sub branches, just like GIS, GPS, remote sensing, Lidar, GPR, etc. So I have tried to cover a few in this session. Such. So if anywhere you have any doubt, you can stop me and we can try to solve the questions. So as I told that all these things, GPS, remote sensing, GIS, they are known as the 3S technology. As you can see, they all share the letter S. And some people call it as a 4S because surveying is also a part of it. And surveying nowadays is being done by the modern techniques. Like most of you might have seen the survey exercise by the conventional equipment like label, theodolite machine, etc. But nowadays, survey has also been improved by new techniques, and satellite remote sensing is one of the techniques which is helping in updating the map and getting new information about the ground. So we will see about it. Topographic lidar also is one part of geomatics which is getting popular these days. Geovisualization, because everything is an information system. Basically, if we want to understand a phenomenon in a better manner, visualization is the best approach. What is visualization? I think you all see the television news. If they want to explain any event, what they do, they try to explain it with the help of animation and just by marking that this is the animated report of that particular event, which helps everybody to understand it. And the same thing we can do for science also. Geo means earth. So visualization of the earth feature comes under geovisualization. So much work is being done in this also. If we try to see geomatics as a glance, we can say that it is the integration as we have seen earlier. It has got so many names, like it is also known as geoinformatics. And nowadays, they also like to call it as a geospatial technology. Instead of geomatics, to make it more clear, geospatial. It is a decision-making tool. Market potential is too much, $2 billion US annual, as well as it is increasing every month or year, spreading at 9 to 12% annually. And India is one of the hub for emergence of the geomatics, and the basis for spatial information infrastructure is geomatics. Now, we will go section wise. First of all, we will like to cover GPS. You can see that GPS is a satellite navigation system. We all do navigation. You all might have seen the car rallies. So in rallies, apart from the driver, there is one more helping person who is the navigator. Navigator is just to tell that which is the correct path. So GPS can be used to find out the correct path, since it uses the satellite technology in order to navigate, in order to get its position. That's why we call it as a satellite navigation system. And what is the advantage? GPS can give you the instantaneous position. Whatever are your coordinates, it can give you this instantaneous data for that. And how it is useful? No other survey technique. Like survey technique has been established a lot. It is being used since centuries. But even any survey technique can't give you the instantaneous position that is given by GPS. That's why GPS is a new technology innovation. Although now it is almost 2 to 3 decades old, but still everybody likes it because of this quality. Apart from position, it can give you velocity and time, because it is a good timekeeper. Then the displacement in position divided by time is the velocity, so it can give you that also. It gives the information almost anywhere on the globe. It is not like our mobile network, which works only when the service provider is there. It means GPS service provider is for the entire globe at any time. It is not like the FM radio, which works for a specific time, but it works 24 hours in any weather. It can even work in the bad weather, although the signal quality may be weak, but still it can give you data. It means you are stranded in some strange location, weather is bad, still you can rely on GPS to tell you about your position and to take you safely to the correct destination. Various GPS systems are Navstar by USA, GLONASS by Russia, Galileo by European Consortium, VIDAS or VIDAO national, this navigational satellite system by China. From Japan, quasi-zenith satellite system, QZSS. India also has its own system, that is IRNSS, Indian Regional Navigation Satellite System. It has been renamed to NAVIC very recently. So out of these, first three are the global systems which can work for the entire globe. Fourth, fifth, and sixth by China, Japan, and India is a regional system. It can work only in a only in the specific region. It means the country as well as the surrounding neighbors. So Navstar is the most commonly used. It is the oldest system. That's why normally more literature is available on the Navstar, and we use it as a fundamental. Whatever new things are given by other systems, that we study separately as such. Okay, Navstar is under US Department of Defense. Basically, it started for the military operations, but later on they started giving permission to the civilian use also. So it is the worldwide navigation and positioning resource for military as well as civilian use for 24 hours as such. And still US military has got the supremacy over all the signals. It means any time they can stop the usage of their GPS by the civilians. They can encrypt the signal. They can induce some errors in the signal. That's why every country or different agencies, they thought that they should have their own GPS system. That's why you know that GLONASS by Russia and Galileo by European Consortium and other countries, they tried to have their own system so that they don't have 100% dependency over the US system. GPS can provide positional accuracies ranging from 100 meter, 5 to 10 meter. You may be thinking that why at all we use such a coarse system, such a system giving poor accuracy. But you know that if you are moving and trying to click the photograph, what will be the quality of photograph? If you have a normal camera, the picture will be blurred. Same thing is here. Navigational GPS can be mounted over a car. That car will be moving at a speed of 50 to 100 km per hour. So there you don't expect an accuracy of 1 meter as such, but you just want to know whether I have reached New Delhi, whether I have reached Panipat, Sonipat. That is okay for me because I just want to know where I am, what is the nearest location. So then 100-meter accuracy is okay in that particular condition. If you are moving with like a slow moving vehicle, or maybe you are working with the instrument, then 5 to 10 meter accuracy will come. If you can stop at a particular point for few minutes and then try to take the observation, then it is like it is able to give you 1 to 2 meter accuracy also. And all these are possible by the navigational or the handheld GPS receiver, which is quite cheap. So it is a basic type of receiver, but if you want to go for a better accuracy, then you have to go for a geodetic GPS receiver, which is costlier than this. Okay, I just I can give you a comparison between the two receiver. Maybe normally cost is not the criteria, but it is it can give you some idea. navigational GPS receiver, if it is coming in 8 to 10,000, geodetic GPS receiver, it starts from 2 lakhs or more. It goes up to 8 to 10 lakhs, etc. Okay, so obviously, geodetic GPS receiver is giving you more accuracy of few centimeter or few millimeter as such. And we can see that naturally the higher accuracies involve a greater infrastructure and thus the greater cost. Now, GPS segments like are very interesting things. So GPS can be divided into 3 segments: space segment, control segment, and user segment. So in space segment, we have got the satellite constellation. Satellites are moving in a particular manner. Like this figure is for Navistar by US. So it has got 24 satellites in 6 orbital planes. Can you see the orbital plane? Look, if you are able to see the mouse, this is one orbital plane around the Earth. This is a second orbital plane, third orbital plane, like this. So satellites are in 6 orbital plane, total 24 satellites. It means 4 satellites are in each plane. They are moving at an altitude of 20,200 kilometers above the surface of Earth. That is a really very high altitude. They have got inclination. You see that all the orbits are inclined orbits. Okay, so they are having 55-degree inclination. So, like, how come these orbits are designed? Orbits are designed in such a manner that at a particular time you get minimum of 4 satellites to capture your data. Why 4? We will study it just after a few slides. So, you can say that, oh, there are 24 satellites. I will get normally availability of even half of the satellite. No, it is not like that. You see that Earth is divided into 2 hemispheres, northern hemisphere and southern hemisphere. So when we are in northern hemisphere, you can't see towards southern hemisphere because it is on the other side of the globe. So out of the 24 satellites, 12 satellites will be on the other side of the globe. All right. When we are moving for taking the data, sometimes we are just standing near a high-rise building or maybe near a mountain, etc. So one quadrant of the globe is again hidden in front of us. So what happens? Only 1/4 globe is available to us. And what is 1/4 globe? 24 divided by 4, it is 6 satellites. Out of those 6 satellites, some satellite may be about to set, some may be about to rise. So what happens? At least you should get 4 satellites with you in order to capture the data. Just I wish to share one thing. Normally, when we take the data in the valleys, etc., sometimes we have to wait for 1 hour or even more than that in order to capture the position, because 4 satellites are not available at particular time. All right. So GPS says that 4 satellite means you will get sufficient accuracy. That we will see just after a few satellites and this few slides. Second one is a control segment. You can see that second segment is a control segment. Third segment is a user segment. So control segment has got few control stations, and these control stations are located around the equator in order to have a better coverage of the GPS satellites. All these control stations are under United States because this GPS belongs to US. Colorado Springs is the master control facility, or you can say that all the correction signals and other things, they can be uploaded from this place. Okay, so we have got this as a control segment. And next, we have got the user segment. We all belong to user segment because we have this equipment and we are using it. And basically, the data from the satellites are being received at this location. So these are the spectra of various receivers, just like your mobile phone. So many companies are there in the market. So these are the navigational, sorry, these are the navigational or handheld GPS receiver, just like mobile phone, very compact. Okay. And then we have got the geodetic receiver. Geodetic receiver is just like a multi-component receiver. we have all the things separately, as you can see in this slide, that this is the antenna, this is the controller. Below we have got the battery pack, etc. So we have got all these things separate because we want higher accuracy, the data capturing capability of this particular geodetic receiver is better than navigation. Then this slide shows that working with GPS using the all three segments. You see satellites are there in the sky. Satellites are giving data to the control station control segment. The linkage is shown by the red dashed line, but you can see it has got arrow on both the sides. It means the control stations can receive the data, they can upload the data also. It means that if there are some correction signals or some instructions that can be uploaded to the satellites from the control segment, that reverse communication facility is not available with the user. Why? Because then every user will try to command the satellites. So satellite system can't work like this. So yellow line means you have got one-way communication, and the user on the ground receives the data from the satellite and it captures the information. So this is again a very interesting picture. It shows that GPS can be used on the three places of the earth, like on the land, in the sky, and on the water. Please note this thing. In the sky, how we can use it? Because normally aircrafts fly at the elevation of 10 kilometers from the surface of Earth. GPS satellites, they fly at an elevation of 20,200 kilometers. It means it is very high in comparison to the aircrafts. Aircrafts can use the signals from GPS to find out its position. Although aircrafts have got multiple type of systems in order to get its coordinate, but GPS is one of them. So it means that aircrafts, they feel more security when they have got the satellite signals to find out whether they are going at the correct path or not. So you can see that it can be used over a car also, or a person standing on the land body. It can be used over a ship also, which is sailing above the water, but GPS can't be used in a submarine. It means underwater. GPS can't be used in the cave or the underground area. Why? Because GPS signals are very weak. They cannot penetrate water, they cannot penetrate land. In fact, GPS can't be used even inside the buildings. Okay? If you have used the GPS and you have entered the buildings, so the signal will break. All right? Now, the most important slide about which we discussed earlier, that why minimum of 4 satellites are required in order to calculate a 3D position in the GPS. So 3D position, we have just assumed there is an unknown point which is having coordinates as X, Y, and Z. All right. So the 4 satellites in the sky are shown over here. These satellites like instantaneous position. We know that satellite is moving in the orbit, but instantaneous position of this satellite is given as X1, Y1, Z1 for first satellite, X2, Y2, Z2, X3, Y3, Z3, X4, Y4, Z4, and R1, R2, R3, R4 is the ranges, the distance between satellite and the ground point. Now, we know one very simple principle of mathematics, that is a polynomial equation. So what is the unknown here? Unknown here is X, Y, and Z, small x, y, z, and all other data is known to me. So what I can do? I can create 3 equations, which says R1 is equal to square root of x1 minus x whole square plus y1 minus y whole square plus z1 minus z whole square. What it says, it is the equation between the 2 points for the distance of that. So I have equated the distance with all these parameters given to me. So first equation is for R1, second is for R2, third is for R3. How many unknowns are there? 3. How many equations I want? 3. Then why at all in the beginning or earlier also we always say there is minimum of 4 satellites required? The reason behind that is the way of working of GPS, this distance R1. We have discussed that satellites fly at an altitude of 20,200 kilometers. This R1 is more than that. Then what will happen? Basically, that distance can't be measured physically. Okay, we cannot measure it by the physical means. How that distance is measured? This distance is measured by the time of travel of the signal. The signal travels from the satellite, it is being received by the receiver, which is at this unknown position. So now time of travel multiplied by velocity. What is the velocity? Velocity is the speed of light, 3 into 10 to the power 8 meter per second. So this particular quantity R1, it may have certain degree of error if time is not computed properly. All of you please do a simple exercise. The speed of light is 3 into 10 to the power 8 meter per second. If we can compute our time by 1 microsecond accuracy, we don't care about a few minutes, then we don't care about a second. And here, if we don't care about even a microsecond, then what will happen? The error in distance will be 3 into 10 to the power 8 meter per second, that is velocity, multiplied by 10 to the power minus 7 seconds, that is the time error. How much it comes? It comes as 30 meter error. Okay, so you can imagine that while taking all the precautions, while doing everything in a proper manner, still we can have an error of 30 meters. So that is not acceptable. So in order to compensate for that, we use the 4th satellite, that is the range 4. So range 4 or the 4th satellite is used in order to apply the corrections. Okay, corrections are applied over the quantities so that we get a proper, accurate this XYZ position out of the GPS. All right, is it clear to everybody? Now we say that simply getting 4 satellites in the sky is not sufficient. The proper location of the satellite is also important. So we say it in the form of GDOP. GDOP stands for Geometric Dilution of Precision. All right, so you see that GDOP is an indicator how good the signal is and how, what is the final computed accuracy. So you can see here that if the satellites are spread from each other, you will be able to get a better signal. That's why we say some angles are better than others. If the satellites are very close to each other, just like that, if they are concentrated in the single area, the triangles formed by the satellite, they produce acute angles. While here, they produce obtuse angles. The angles are very wide. So we say that wider angles are better, but narrower angles are not good. That's why here we get the poor GDOP. If all the satellites are concentrated in a particular region. Sometimes satellites are spread, good GDOP, but visibility is poor, as I told you about my experiences. If we work near the high-rise buildings or we work in the valley, then few satellites are there, but they are hidden in behind the buildings or behind the hills, so we are not able to capture it. So this gives a problem while taking the data from GPS. So it gives you some idea that as such taking the GPS data is not sufficient. You have to be considerate about the errors in the GPS also. The signal while coming from the satellite to the Earth, it has to pass through number of atmospheric layers. While in this you can say, highest zone. It is vacuum. But as you come closer to the Earth, the signal has to pass through the atmosphere. And due to interaction with the atmosphere, the signal goes zigzag, zigzag. So the distance which we are measuring, we assume that it is the signal is coming in the straight line, but signal is coming zigzag, zigzag. It means time of travel increases. So the computation of distance or the R1 distance, range distance is not accurate. So all those things need to be corrected here. So you see that like apart from that, other type of errors are the satellite clock error, receiver clock error. This also has one very interesting thing. Satellites have got atomic clocks. Receivers have got quartz clock. Atomic clocks are having accuracy of 10 to the power minus 10 seconds. Receiver clocks are having accuracy of 1 microsecond to 0.1 microsecond. So there is a mismatch between the accuracy of satellite clock and receiver clock, but we are helpless. Why? Atomic clocks cost about $1 million. If you put atomic clock in every receiver, nobody can afford to buy it. Okay. If you put quartz clock in the satellite, so all the GPS data will be erroneous. That's why at least for the satellite level, we are using the atomic clock. For the receiver level, we are using the quartz clock in order to make it cheaper. Then there is ephemeris error. What is the ephemeris error? The satellites, when they move in the sky, they don't move in the, you can say, theoretical orbit. They don't move in the calculated orbit, but due to space storms, magnetic anomalies, etc., they don't travel over the designed path. They just move slightly away. So you see that the coordinates x1, y1, z1, which we have calculated for the satellites. You remember this x1, y1, z1 for the satellite, x1, y1, z1, x2, y2, z3, etc., etc. The coordinates which we have taken from the theoretical orbit is not correct. So if you want to apply the correction, we have to apply after getting the real orbital data of the satellite. All right. Next is the atmospheric error. This atmospheric error you can see yourself. Due to composition of different atmospheric layer, you are not getting the straight line signal, but the signal is moving zigzag. Next is a multipath error. What is a multipath error? So signals, when they are coming from satellite to the ground, and the ground, location, the receiver location is surrounded by some hills, etc. So signal will be coming to the location first, but it is also coming by multiple reflection from different sides. All right, so there is confusion that which signal should be considered as correct. So even if the averaging is taken for that signal, so it induces the error. All those things. That's why we say that we need to check for all these things before taking the GPS data. So now, last one is the selective availability. In selective availability, as I told you, the company or the service provider of GPS can introduce error intentionally so that nobody can take the correct data in the real time. So what is the fun behind that? So what the particular country, just for example, US, what US want, nobody should attack US using its system only. Okay, using the GPS which is designed by US, anybody attacks US with that. So just in order to prevent all these things. So like nobody wants that type of stage. That's why they can introduce some selective error in that data, which can be removed after some time. So it is not used for warfare, but it can be used for science. It can be used for research. So again, this is a receiver noise error. You can see that signals are not going straight. This is a very important slide which I normally tell to every user of geomatics. Basically, what happens if you take a single GPS receiver data, that is the static data, basically that is a standalone data. So you get it, and if you take a longer time signal, you will get more accuracy. But if we can use a pair of GPS, if we have got two GPS, then what is normally done, you can keep the GPS at a known station, just like it is shown over here. So GPS and the radio beacon on the reference place. There is a rover receiver which is moving around in the ground. So what happens if you take the data collectively? The data is taken at the same instant by the GPS receiver at the known position, by the GPS receiver at the unknown position. So it is assumed that the same satellite in the sky will give the data to that, and the amount of error, maybe due to atmosphere, due to any other thing, amount of error will be same in both. All right. So what will happen if the signal at this known station is 1000, 2000, which is having an error of +1 and -2, the same error will be there in all the observations which is taken at a particular moment. So whatever data is recorded by the roving receiver, if you apply that correction to the data, so it has been checked that the signal quality or the accuracy increases too much. It is known as relative point positioning. It means in relation to some known point, you are trying to correct the unknown point. And here there is one more thing in that correction signal. That correction signal can be corrected in the laboratory. So after you come back to the laboratory, then you can compare the two data for rover and reference. Or there is one more option. You can correct this data in the field itself. For that, as you can see over here, radio beacon. If your ground station or reference station has got a radio beacon, then the data can be directly transmitted from the known station to the unknown station. So it will give the instantaneous correction to the data. And this transmission of data by some link is known as RTK system, real-time kinematic system. All right. So the previous question is unanswered, that why it has got so much importance. The importance is like this. You contact any GPS vendor. GPS vendor says that I am selling you the DGPS. Okay, because nowadays DGPS or differential global position system has become a respectable term. So they tell that I am selling you a DGPS, and persons who are ignorant of the technology, they happily purchase it. The vendor shows them the research papers out of the very reputed journal that what is the accuracy of DGPS in centimeter or millimeter, and everybody happily purchases that. While what I want to tell you, DGPS or differential GPS is not the equipment, but it is the method. Okay, using your navigational GPS receiver also, you can do the differential position. All right, is it okay? So although the correction software in the navigational GPS is not very strong, but the same exercise can be done with that also, either manually or by the computer. Nowadays, in the navigational receiver also, facility has been there that you can upload entire data to the computer. So by uploading that data, you can apply all those differential corrections. Is it okay? That differential GPS or DGPS is not the equipment, but it is the method. Now, few applications. It is useful in mobile mapping. useful in location-based services. It means I want to search a petrol pump, I want to search a restaurant. Emergency services, I want to just find out a police station, I want to find out a motor garage for repairs. To track a particular car is moving, the owner can track where it is going, etc., etc. So car GPS, so I hope nowadays most of you must be using it, because in the car you have got GPS as well as GIS. Wherever you want to go, simply enter the location and it will take you to the required place. You see that from origin to destination, finding out the optimal path can be used. That Galileo has got, because it's a private, Galileo is from private, and for some of the services you need to pay. Like as such, normal GPS is free of cost. You have to simply pay for the receiver. No need to pay anything for the service. But in Galileo, you have to pay for the services also. But what advantage it can give you? It can give you the this added support for recreation, road transport, location-based services, agriculture, fisheries. Just to summarize, if anybody want to communicate with the GPS receiver, that facility, limited facility, it is not like you are uploading your commands to that. Limited facility is available. So if any person is lost in an unknown area, maybe ocean or desert, they can give a distress signal or SOS signal to the GPS so that they can be located and rescued. All right, so this is one of the advantage which is possible by the Galileo, but Galileo is not fully operational yet. So I hope in like future, when it will be operational, it will give you very good services. So this is the mobile-based mapping. You have got a palm top. In that palm top computer, you have got the map, you have got the GPS. So wherever you are going, you are recording your location as well as you are just writing that what that feature is. So it means that map on the go, you are moving and creating a map on the ground. This is again the ITS, Intelligent Transport System. So in your car, you can go to your destination, and if you put it over a train or a bus, etc., then you can use the automatic vehicle location system, that where it has gone, whether it is on the prescribed path only, or the train has gone somewhere else where it is not scheduled to go, etc. So this portal is showing the fleet management. Suppose a person is having a fleet of vehicles. So here by having this online monitoring, he will be able to manage all of these very efficiently. So with this, we end the satellite remote sensing part. Sorry, we end the GPS part, and then we go for the satellite remote sensing. As the word says, the remote sensing. Remote sensing means we are observing a place remotely, and what is helping us? Satellite is helping us. It means we are taking the data from the satellites. All right. So you can see that in satellite remote sensing, sun is the major source of energy. Energy from the sun is coming to the earth and it interacts with the ground features, and same signal is captured by the receiver of the satellite. All right, so this is the remote sensor available. So the signals are being captured with that. You can also see in this manner, sun is giving you energy. So here few more phenomena are shown, like the energy when it is coming from the sun, it has to pass through atmosphere, and the atmospheric constituent, they have got their own role. So some of the energy is absorbed. Can you see? The mouse, some of the energy is absorbed, some of the energy is scattered, etc. And some of the energy is absorbed as well as scattered. So basically what happens, that the signal when they are being received by the satellite, they have got certain errors. Those errors have to be removed before going for the analysis. So with this, we can define the remote sensing as remote sensing is the science of acquiring information about the Earth's surface without actually being in contact. Because in surveying, in the normal surveying, we are doing near sensing. It means we are directly going to the ground and collecting information. But in remote sensing, you need not go to the ground. You are collecting the data from a far place. Suppose it is a satellite which is giving that, which is capturing the data and giving to you. You need not go for the field. Okay, you can simply create a map from that place. So this slide shows that the energy which is coming from the sun, it is incident over various features on the ground. Like it is incident over the built-up area, and built-up it is interacting with a high rise, a medium rise, or just the huts type structure. It has got some interaction with the paved roads, bare soils, grass, water, forest, etc. And now there is one basic thing which is very important in remote sensing: the radiations. Okay, the radiations which are coming from the sun and which are incident over these ground features, they interact in different manner with these objects. All right. So what happens? You can identify the object on the ground by the interaction which they have with that signal. So due to this different interaction, the signal characteristic will change, and over the satellite, whatever information it collects, we are able to identify the objects on the ground. All right. So this is known as the multi-concept of remote sensing. Basically, it is the multispectral concept. Multiple wavelengths, they behave in different manner with different objects. So this multi-concept, it helps you to identify. Suppose all of these, all of the ground feature, they give the same response to the ground signals, then what will happen? Over the satellite image, you get the uniform signal and you will not be able to identify from where this signal is coming. All right, so this characteristic, the multi-concept of remote sensing, it gives you very good information. This is the orbit. Remote sensing can be done by two type of orbits. One is the geostationary orbit. I hope you all know about it. This orbit is above the equator. Satellites are moving around the Earth above the equator. Second type of orbit is a polar orbit. Polar orbit means satellite moves from North Pole to South. Okay, so these two type of orbits are prevalent for remote sensing. So out of that, the geostationary orbit is not very much useful, but the polar satellite orbit is very useful for the remote sensing satellites. So you can see the details. So again, can you see that this orbit is above the equator, an equatorial west to east orbit. So we say that altitude is very important, that is 36,000 kilometers. And how come this 36,000 kilometer is designed? So they all depend on the Newton's law of motion and the Kepler's law of celestial bodies. So it gives us the relationship that if the satellite has to move at 36,000 kilometer, the orbital period, the time in which it completes one orbit, that is the time of revolution, is 24 hours. So what is the advantage of 24 hour over here? That advantage is, suppose my satellite is above the India, okay, then the globe is moving, satellite is also moving. So every time satellite is in lock with the Indian ground station, okay, because when the Earth is moving, that ground station is moving, satellite is also moving. Earth is taking 24 hours to complete one full circle. This your satellite is also taking 24 hours. That's why these satellites, the geostationary satellites, are very good for communication. It means in order to have the live telecast in order to have this internet telephony. So all the signals are given, that internet signals are uploaded over a satellite, or you can also say that for the satellite phones and like for all the type of communications, basically is done by geostationary satellite. Meteorology, you want to monitor the cloud movement, you want to monitor the climate over India for the 24 hours. These satellites are always above the this Indian subcontinent. It will be useful for the meteorological operations. All right. So out of all these satellites, GEOS, Meteosat, INSET is the Indian series. I hope you know about it. All right. So INSET satellites are the geostationary satellite which are which are owned by India. Next comes the sun synchronous satellites. In sun synchronous satellite, they have got a near polar. What is a near polar? If they would be passing from North Pole and South Pole, then it is a polar orbit, but the orbit is slightly inclined. It means that in the northern side, it is passing through, it is passing near the North Pole. In the southern side, it is passing near the South Pole. So it means that orbit is slightly inclined. By virtue of being inclined, it can establish the sun synchronous characteristics. So what is the sun synchronous characteristic? Just understand it by the simple example. You know that Earth is moving over its axis and different places on the Earth are coming. You see that sun is here. Sun is giving the energy because sun never rotates around the Earth. Sun never revolves. So Earth spins over its axis as well as it revolves around the sun. So basically what happens? Different locations on the ground, they just get the sunlight by the change of hour. Sun is giving light to them. So what happens over here, if the orbit is inclined, like suppose here it is 9 o'clock in the morning, by moving the half cycle, it comes here at 10 o'clock in the morning, but by that time this Earth location moves, and in 40 minutes or 45 minutes, it comes in front of the sun. What is the advantage? Solar illumination, solar light is same at all the places. So it is just like capturing the photograph with the same solar conditions, with same solar light. So what will happen? You are able to compare the photographs much easier manner. In place of one photograph is taken in low light, other photograph is taken in the bright. All right. So it is known as the sun synchronous orbit. Orbit is synchronous with the solar light. Wherever the sunlight, or you can say sunrise, is there, the places are coming in front of the sun in order to get equal amount of sunlight for capturing the photographs. Photographs can be very easily compared. So this is what has been written. Earth satellite orbit in which orbital plane is near polar. Altitude is such that satellite passes over all the places having the same local sun time. And examples are Landsat is American series, Spot is the French series, IRS is Indian series. So all these satellites and other type of characteristics are decided by this orbit. Now we have got a few very good animations. Basically, when the data is captured, it is either captured in the frame base, just like we take normal photograph. It can be captured by just taking the data for across track, like satellite is moving forward as well as it is taking data in the perpendicular direction. Next type of data is satellite is moving and capturing the data at the same time. So we will try to see them one by one. Can you see it? It is a frame based. So frame is captured at a single click of camera. All right, you want to see it again? So it is a frame-based view. So, and you know that it is taken for a rectangular portion for the width of the Earth. Next one is a cross track. So satellite is moving forward, but it is taking data for the sites like this. So look, these are the strips which are captured by the camera, and the strip is for a particular width on the ground. So the view angle of the camera, it takes a particular strip on the ground. So that strip is known as the swath. All right, you have seen this also. Next one is a long track. So satellite is moving forward as well as it is just like sweeping. All right, so it is also known as the push broom camera, just like you are carrying a broom and just sweeping the ground. So these are the along track. Indian satellites, they adopt this technology, that is the along track. All right, so we go further. This is the Indian space program, a spectrum of satellites. So many satellites are there in the sky, and the range of details are from 1 kilometer to 1 meter, giving global coverage. You can cover almost entire globe. And one advantage of Indian data is it is very cheap in comparison to international one. Although nowadays Google Earth has started giving very good quality data and without any cost, but that data is not for any DIP, digital image processing related work. The data is just for viewing. So if anybody want to work in digital image processing, then they have to capture the multi-spectral data, multi-wavelength data. So like in the world, this is having a mixture of national and international satellites. You have got a wide variety of satellites. NOVA, AVHRR, a single picture can cover almost entire country like India. Then we have got OCM. OCM is Ocean Color Monitor from India. It can cover almost 1/3 part of India as such. Then we have got WIFS, Wild Field Sensor, again Indian. You can cover almost full or half a state by a single scene. Then we have got list 3. List 3 can cover one district, etc. List 3 have got this aerial coverage of 140 by 140 kilometer, which is quite good to cover a district, etc. Then we have got panchromatic camera. Panchromatic camera, and you see that as we move forward, we are getting a better ground detail. The ground detailing is better, as you can see also with all these type of pictures. So basically, you can find out that you will be able to see the ground in a much better manner. So after this panchromatic, you can go for again this Iconos data is also giving you the panchromatic as well as multispectral, but the ground detailing is better in comparison to that one. So this is what I was telling you, spatial resolution of ground detailing. You see that same area, 32 by 32 kilometer, 84 meter, 64 meter resolution, you can see the ground like this. Then 16 by 16 kilometer, 32 meter, you can see the area, this dam and river system in a better manner. This is 16-meter resolution. The area is slightly better with more detail. It is 8-meter resolution. And you see that the aerial coverage reduces at the same time. Earlier it is 32 by 32. Now it is 16 by 16, 8 by 8, or 4 by 4 kilometer. You can even go further. 1 kilometer by 1 kilometer, 4-meter resolution. Then 500 meter by 500 meter, 2-meter resolution. 250 by 250 meter, 1-meter resolution. All right. So it is for this. And here you can see this detailing. It is a White House. You see at a resolution of 1 meter, 3 meter, and 10 meter, how clearly you can see the detailing on the ground when the resolution is better. All right. So again, a car parking area, you can even identify the car type. That's a very good resolution. This satellite data is available. It is the fighter plane at a resolution of 6 inches or 15 centimeter, 24 inches or 60 centimeter. You can even see that what type of rockets and other things are connected. So it is New Delhi Rajpath area. It is like panchromatic data at 5-meter resolution, 5.8 meter as such. So it is panchromatic data of Houston city at 5 meter. This is the test. It is a Indian satellite, but the data is not made public too much. So the quality of data is very good. You can see it is a Barcelona airport. So we can see very clearly how the planes are parked over there. So this is the hangar, etc. All those details are very clearly given. This is a perspective from a test satellite. So it is just like the aerial photograph. So although this satellite, it flies about 600 kilometers plus, is higher than that, but still it gives you very good quality data. So it is a Colosseum in Rome. It is a part of 7 wonders. So 1-meter resolution Iconos data. It is being displayed very good. It is now that false color and true color composite. True color means whatever we see with the eyes, same color combination we see, but sometimes false is better. Why false is better? Because it can show us some more information which our eyes can't see. That's why in comparison to the true color or natural color, in geomatics, we go for the false color. How? The infrared energy, the infrared signal is also incorporated in this particular view or this particular data. Infrared gives us some extra information about the ground in comparison to our visible data. That's why we say that false color data is better than the early. So this is the coverage of cyclones, etc. by different satellites or different sensors. South India and Sri Lanka, there's cloud movements, etc. can be measured. And you can see that Adams Bridge, the connection between India and Sri Lanka, they can be very clearly viewed by this picture. These satellites, the modern satellites have got one more capability. Like although they are designed to look down, they are designed to look vertically down, they can also tilt the camera in order to see the area which is on this nearby side. What is the advantage of that? One advantage is you can take the stereo data. What is the stereo data? It means that if the same area is viewed from 2 angles, just like your stereophonic sound, it gives a better soothing effect to our ears. Same thing if the same area is viewed from 2 sides, then you can compute the elevation out of that. That is a stereo satellite data. So if you try to create the distal elevation model out of it. So that is one capability. Second capability is if some important phenomenon is going on, just like some cyclone, flood, or some other thing is going on, and you want to monitor it every day. So basically what can be done? You take the data from this particular location, and when you go to the nearby orbit, you again tilt the camera and still you can keep on viewing the same phenomenon on different sides. I hope you are aware that satellites have got a specific orbit, and satellite comes to the same location after 21 days or 25 days as per the characteristic of that particular satellite system. Okay, so if you want to see the same phenomenon at an earlier date, you can just tilt the camera and view. You can see that it is a picture of Hurricane Andrew. So how it moves, I think you can, you must have seen it on the television also. They give you the satellite picture of a particular hurricane event or other thing, that how it is moving and hitting the ground. So this is one more interesting picture for the ground. I hope you all know about it. It is Eiffel Tower. Okay, I hope you can just identify it as the Eiffel Tower in Paris. So this picture, if you compare with another picture, you can just see a lot of similarity. Okay, this is the Eiffel Tower. If you compare it with the another picture, lot of similarity is there. Again, I can toggle between the two. The difference between this is an aerial photograph. This photograph has been taken from, and you can say, a flying object which is flying at an elevation of 2 to 4 kilometers. But this is taken from a satellite which is flying at about 800 kilometers. So you can compare that. Nowadays, satellite cameras are of very good quality and they can provide you very good pictures of the ground. So earlier, we used to go for the aerial photograph only in order to capture the photographs of the ground. But now we can take the satellite. You can see that even the boats, etc., which is moving in this scene. I think Paris is on the bank of Seine or Rhine. I'm confused. Okay, but all the ships and boats, excuse me, which are parked over there, they all can be viewed very clearly. So this is one example of good quality satellite picture. This is a picture of Lotus Temple, New Delhi. I hope most of you have seen it. This is Judge Harry Ferguson Interchange, Los Angeles. Very good location for the Hollywood movies, for the motor chase and other things. This is again interesting thing. What are these circles? These circles are the irrigated fields for the with the sprinkler irrigation. All right, you know that in desert area in Middle East, etc., they have scarcity of water. That's why they have the sprinkler system. The sprinkler, it just sprinkles water in a circular reach. So wherever the water is available, they sow the crop only in that, and they leave the remaining area. They have plenty of land as such. So this particular circle is for the crop, and it is the agricultural lands with the sprinkler system. This is the rice field. See that the step cultivation for the rice. This is the cattle farm. Okay, so individual cattle, how nicely they can be viewed from the satellites. This is again for urban planning, the different type of road systems and the circular way of housing, etc. This is the Pentagon type of structure, barefoot bay development in the Florida. So all these things will be easy for the urban planners and those who are interested in this type of things. It will be better if they use it. This is again one more interesting capability. This is a digital elevation model, which is just like a fly-through. Okay, you see that these all are created by the satellite data with the elevation model, etc. So you can create this type of system, and it is just like you are flying above the terrain. So same type of thing can be done. So this is the Goa area, and river Mandovi and nearby mountains can be seen. For that, on the other side of it, there is the sea. You see that the lower side, the Mandovi river, it meets the sea, etc. So it gives you a very good idea about how the area is. Next topic is Lidar. It is light identification and ranging. This particular equipment, it uses the laser beams for capturing the data. So the tool, earlier we were using the electromagnetic energy. Here the tool of light is laser. Operating range, ultraviolet, visible and infrared. So many wavelengths can be used. So laser, I hope we all of us know light amplification by the stimulated emission of radiation. How come it is useful in geomatics engineering? It is useful because laser can be pointed very sharply over a location. So whatever data we capture using the laser sensor, it gives us the signal with very high accuracy. That's why laser has got a good reputation in all those things. You see that typical laser technology. Again, laser can be flown on board aircraft, on board a satellite, and you can have the sensor on the ground itself. The ground sensor is known as TLS, terrestrial laser scanner, and so many users use it for number of purpose. I have got some outputs of that, and we can see all of those. So it is the picture system, that ALS 50 is their airborne system. So you see that it shows you like how it works. So as you can see with this animation, advantage of that laser is when you fly, you can get multiple return out of it. So when the camera is at this location, like area below it is the bare ground, you can capture the signals. You can call it as a first return and the only return because no other feature is there. After that, when you just hit this features, so first hit will be at top of the tree. So that is the first return from the tree top. It these laser signals are quite strong. Your normal electromagnetic signal, at the first hit itself, they return back. But these signals will still go further and further. They penetrate the canopy. And while passing through it, they hit other branches, other leaves, etc. And one return also goes from that place. That is the second return from the branches. It means that you are able to find out location of the top of the tree, location of the branches. It means you come to know that how thick is the tree, and also you are able to get some signal up to the ground. Although you can see the thickness of the line decreases, it means the signal strength is not the same, but still you can get the third return from the ground. It means from the same signal you have got the three outputs, which will be very useful for the analysis. We will see this animation again. So you see that aircraft is coming, first return, only return. Now first return, second return, and the third return. So this is. And now we have got some more pictures from, these are also from the airborne one. You can see the bridge and the nearby buildings can be captured very nicely out of it. So this is the area, and now we have got some more capability, like if you are interested in study of vegetation, you can study that. If you don't want to study the vegetation, you can remove that by the computer processing. All right. You see that vegetated area is removed from some of the part, the ground, and if you want, you can completely remove as per the requirement of the analysis. So this shows the buildings extracted from the Lidar data. It gives you very accurate height. It gives you very accurate ground point. So we can create a virtual environment out of it. So we can just prepare the area which is for us. And it is one way, one laser view of the Toronto waterfront. You can see that how nicely all the details have been picked for the waterfront. Some more pictures out of this. I told you that same sensor can be put over the ground. by a system which is known as TLS, terrestrial laser scanner. So this is picture of India Gate. So although in this picture you are not able to see much details, but if you zoom it further, you will be able to get each and every detail on the ground, because it captures the data very accurately of the centimeter level accuracy. This is Humayun Tomb. Here you can appreciate it with more detailing and other things. And we can, if you zoom, you will be able to get it in a better manner. This is Bibi Ka Maqbara, and it has been told that this is the inspiration for Taj Mahal. So this Bibi Ka Maqbara in Aurangabad is a very, very beautiful structure. So like after capturing it from the TLS, the laser equipment, you can get a very good models out of it. Next, we go to the GIS. You know that GIS is a powerful tool for solving real world problems. GIS is Geographical Information System. It means all the geographical information can be kept one over the other in order to solve some real world situation. Like a very simple situation is you have got map of a river, you have got map of the road. So intersection of river and the road will be the location of the bridge. It may have a bridge, it may not have a bridge. So for the city planners, they want to know that where a bridge is required. So this overlap of these two maps will give you the location of the bridge, whether you just plan to construct it or not, but it can give you idea for solving the real world problems. You see that different type of layers, different type of land use, streets, district, parcel map, all those information is tagged in different layers. Why it is kept in different layers? Because the functionality of GIS says that it is very easy to overlap. All right, you will be able to overlap it very easily. But if you want to segregate them away, like suppose you prepare a street map and a river map all together, and later you want to see them separately, it will be very difficult to make them separate. That's why in GIS, it is always preferred that you prepare everything separate. Like you see that there is some information regarding the parks, etc. Parks, residential colony, industry. You have got sand and gravel, some geology, some water table information. So river and this discharge point of the river, etc. So many information can be captured. So GIS says that we can describe our world in a very simple manner. Okay, so we can describe any element in two ways. First element is the coordinates, location where it is. So that is the latitude, longitude type of information. Second thing is attribute information. So attribute information says that what type, attribute is just like adjective. So what type, what are the characteristics, like you can see here, the species of the tree is oak tree, height is 15 meters, age is 75 years. So it means that it is an important species which lasts for 75 years. That's why I have recorded the location, coordinates, I have recorded the attributes. So this particular feature I can enter in my map for like to be referred at a later date. So we say that picture is worth 1,000 words. So GIS help us in preparation of the smart maps. As you can see that you can prepare India map. GIS gives you the advantage that wherever you take your this mouse, it can give you more information. Like for Uttar Pradesh, Madhya Pradesh, maybe for Rajasthan, you want to click it and you want to know more about that. So you can see that it has given you more information, like for Rajasthan, name of Rajasthan, like how many towns are there, what is the population, what is the people, like what is the percentage of people having pakka house, kacha house, like that, the length of the roads in this. So all this information can be very easily available just by a click. So this is a smart map. Because otherwise, if you want to write the same information over the hard copy maps, the map will become too much clumsy. That's why we always say a digital map with a picture, etc., is very good. If the same information you write in the form of a book, then if the map of India or map of Rajasthan is not available, still people will not be much interested in that. They are not able to visualize where exactly these particular things arise. So now again we have got a visualization 3D view of the flood risk zones of the Allahabad city. So that you can see here with this, you have got like a digital elevation model with the satellite image of Allahabad, and you see that Allahabad is the confluence of two rivers, Ganga and Yamuna. So it is just like a flanked by two rivers, and artificially the river level is increased. So just we say that a normal elevation of water is 79 meters, that is the normal flood level. But if we assume that we want to analyze the flood risk of Allahabad for different type of floods, and you know that in flood analysis we say 5-year flood, it means the probability of flood to occur in 5 years, probability of flood to occur in 10 year, 25 year, 50 year, 100 year. So according to that particular flood threat, if I want to visualize that which area will be safe in Allahabad, so I can plan it like that. I can make some shelter zones in those high areas, as well as I can take some measures so that water never rises up to that level in Allahabad. So you see that if we go for the 5-year flood, then water level rises. So whatever are the submerged area, I need to discard those. Again, for 10-year flood, you see that water level again increases. I think you might have noticed this particular area. Earlier it was clear, but now afterwards this area, oh sorry, increases. So for the 5-year flood, this area was not having any water, but in 5-year flood it has got water. Again increasing in 10 years, this much has got water. In 25 years, more area is submerged. In 50 years, you can see too much area is submerged, and if you go for 100 years, you will see that almost entire lava town will be submerged. So it is just showing the flood threat, that what may happen if that flood with 100-year frequency can come. So you know that this 100-year is a mathematical term. They cannot say that in this 100-year it means for a particular century, like 2000, whether it will come in 2001 or it will come in 2099, because it is just a statistical analysis of that. So we need to be prepared for all this. Okay. So it is the movement of the cyclone. So you see that super cyclone over Odisha, multiple pictures from INSET with different dates. You see that 28 October to 38 October. So different dates are being shown on the top. So how the cyclone is moved, etc. And like aftermath, if you are able to do the measures when the cyclone is coming or before the cyclone is coming, you can save a lot of human life and damage, etc. So basically, like in the aftermath, we can simply say 3.75 lakh hectare of the land is inundated, full of water. The crops in those areas are damaged. Road, power, communication networks are severely affected. That's why we every time says, if we can find out how these cyclones are moving, where it is going to hit the land body, etc., then we can take the relief measures and we can take the precautions in much better manner. Visualization, this is a campus at Dehradun. So again, just by taking the ground measurements by surveying, but a 3D has been created by the software. just to show you like how the 3D techniques are useful in this geomatics. So now you can see that if we say geomatics is a tool for information to solution, it provides you the information and that information can provide you the solution. There are so many applications, like you can say in almost every field it is helpful for agriculture, for forest, for water resources, geology, ocean, environment, rural development, urban management. In cartography, it means like preparing maps and updating maps for the climate modeling, for the global climate change, etc. So almost everywhere this geomatics has got its applications. So with this, we end the discussion part. But if you have any questions, you all are welcome to ask, please.
All the participants, those who want to ask questions, are welcome. Participants can raise their hand. Participants, sir, it seems the entire lecture, because it was like you have explained it in from the very grounded form. So it was very easy to understand, and all the techniques that you have explained is maybe very clear to the participants. So I thank you very much, sir, for explaining all these details and related to the latest trends that geometric engineering is having. And your lecture was like very basic in the form, from the explanation point of view, and very advanced in the form of like with the latest trends that you explained in GIS and geometric engineering. So I thank you very much, sir, for again finding out time from your busy schedule and helping me out in organizing this FDP. So thank you very much, sir.
It's a pleasure. I think one question I can see in the chat box.
Yes, sir.
I think Apurva Gandhi
Apurva Gandhi
asked the question: what is the basic difference between the lidar and radar? All right. So, like the difference between lidar and radar, one basic difference is the use of the wavelength. All right. Lidar is a laser-based sensor where you are having the radiation which are being sent are the laser radiations, and laser radiation may be infrared, ultraviolet, or visible. While in the radar, you are sending the microwave radiation. Microwave radiations are having the range of 1 millimeter to 1 meter. Okay, there are different wavelength band which are used in radar. So the interaction will be as per their capability, as per the characteristic. Radar has got a slightly wider wavelength in comparison to visible, so they can penetrate the atmosphere easily. They are less affected by the atmosphere. They can even penetrate the clouds, and whatever information they are giving, it is very useful for the rainy conditions or the poor weather conditions. All right. So whatever information is given by radar to us, that is important, but that is for a specific purpose. Laser, they are giving us the information with very high level of accuracy. That's why laser data is useful when we want to go for the urban planning, recording the urban features, recording the height features. Then we can say that that laser data is useful. All right. So any other, I think what...
Sir, one more message from Aman Bhatla ji, though the question is having difficulty in itself. The GPS, we cannot collect the data underground. Can we do it with the help of GIS?
So actually, GIS is the data management system. As the word says, Geographical Information System. Okay. So GIS is for data management. GPS is for data capturing. You told that you want to capture the underground data. There is one more equipment that is known as a GPR, ground penetrating radar. Due to that time shortage, I didn't cover because GPR itself might have taken another 20 to 30 minutes. What it does, the signals, GPR work, as the word says, a ground penetrating radar. It sends the microwave signal inside the earth, and inside the earth, if there is any feature, maybe a pipeline or other thing, it sends that signal back. That signals are recorded, and you will get a picture of the underground. Okay, so it means that if you want to capture the underground features, you can work on GPR. If you simply want to say that inside the building or inside a cave, etc., then you can use the survey equipment like total station, etc., which can give you picture. Okay, so underground means if you are not able to enter, you are just observing from the ground, but you want to see the data what is inside, you use GPR. If you want to see inside the building, inside the cave, tunnel, etc., then using the total station will be useful for you. All right.
Sir, another question is what from Dr. Nisha. What is multispectral and hyperspectral?
Yeah, okay. So as such, it is a very minor difference basically when we can say. You see that when we call it as a pan means panchromatic, very wide wavelength. Okay, it means that entire visible spectrum 0.4 micrometer to 0.7 micrometer, even longer. That entire wavelength is taken as a single entity. We are capturing the signal as a single range. But multispectral means out of that larger range, we have taken a small segments. So just like the blue wavelength, green wavelength, red wavelength, near infrared wavelength, that is a multispectral. It means we have taken multiple wavelength ranges out of that broad range, but this multiple is not too much. That multiple is normally from 4 to 10, etc. We call it as a multiple, there's a multispectra. Spectra is wavelength, so multispectral remote sensing. What we do in hyperspectral, we divide that entire range in very, very narrow. This narrow, it means that in multispectral, the difference in wavelength, suppose it is this much, in hyperspectral, the difference will be this much small. So we say that in multispectral, if the wavelength width is 100 nanometer, in hyperspectral, the wavelength width is 2 or 3 nanometer. I hope everybody know what is nanometer, 10 to the power minus 9. It means out of this wavelength range, when we are taking only 4 parts, now we are able to take 40, 100 or even 400 parts. So by taking that multiple wavelengths, by taking that too high wavelength range, we call it as a hyperspectral. Normal hyperspectral satellite, they give you 200 to 300 type of bands. And analyzing that more than 100 bands, we call it as a hyperspectral remote sensing. One more type of remote sensing is being developed, that is known as ultra-spectral remote sensing. So out of this wavelength range, what we are doing, we are dividing it in more than 1,000 wavelengths. Okay, having 1 nanometer or even smaller than that range. So individual band will be very, very, very small. More than 1,000 bands, more than 1,000 wavelength ranges you have to handle. We call it as ultraspectral, although ultraspectral is still in development stage. All right.
Sir, there is one more question. Like GIS is not the specialization of the participant, but from where to start, can you just guide?
Where to start the GIS? You see that whatever data. Yes, any question? Anything?
No, sir. Somebody was unmuted by.
Okay, all right. So basically, you know that starting a GIS, it basically says that you need to create the data layers. All right. Suppose you have got a topographic map. Out of the topographic map, you scan it and prepare road map separately, river and canal map separately, wherever some houses are there, that residential map, vegetation, agriculture map separately. Then you can do analysis for that. Okay, so normally that GIS layers are available for land use, land cover, etc. So with that small thing you can start. And one more thing I wish to share, that you need not purchase a GIS software. Nowadays, QGIS or Quantum GIS software is available free of cost for download. You can download that software and it has got very good capabilities. So one need not purchase a GIS software from the market if they want to start it. And there is one more question I can see, that from where one can get the hyperspectral data. So you see that Hyperion satellite is a very popular satellite. You can get that Hyperion data free download from the internet. Although there may be a limitation, Hyperion has got a very narrow width of information, so it is not available for the entire globe. So maybe possible you may or may not get for your area of interest, but again, it is very good to work. The data quality is good. For working on hyperspectral, you need a specialized software like NV, etc. Because the number of bands are too high. The normal software may or may not be able to handle those much. Okay.
Sir, these are the questions that people are thanking you for your lecture and they're replying the comment. So thank you very much, sir.
All right. Okay then.
Thank you, sir.
Okay. Thanks to everybody for the patient hearing, and thanks to the organizers. Okay. Thank you, Dr. Pawar. Bye. So now
Sir, as soon as you'll be back, I'll give you a call. Like
Sure.
once you'll be back from the gate examination, I'll give
Yeah.
you a call. I'll wait for the performer, sir.
Okay. It's okay.
Thank you, sir. Thank you, sir.
Okay.
Thank you very much, sir. To all the participants, our next speaker will join within the next 5 minutes. Professor Milap Punia from Center for the Study of Regional Development, School of Social Sciences, Jawaharlal Nehru University, New Delhi. So, sir will be speaking on water resource sustainability. He'll join very soon. Let's say next 5 minutes he'll join. So you all are requested to kindly wait in the meeting room only, the Zoom meeting only by the time. So thank you everyone. Thank you. Sir, good afternoon. Now it's up to now, it's good morning only. Sir, good morning, sir.
Hello.
Sir, good morning, sir.
Good morning. Good morning, Manoj.
Sir, I thought you are unable to like unmute your mic. So
नहीं मैं थोड़ा सा इसको सिस्टम को दुरुस्त कर रहा था.
okay, sir.
Just give me a minute.
Yes, sir. Yes.
Hello.
Yes, sir. Sir, good morning again.
Very good morning, Manoj जी. बताइए अभी
So-
चालू करें या?
Yes, sir. Yes, sir. We can start, sir. So, welcome to all the participants to the second session of the day 2. Professor Milap Punia from Center for the Study of Regional Development, School of Social Sciences, Jawaharlal Nehru University is there with us. So, sir has done his sir is a alumni of very famous Birla School from 1991 batch. Sir is MSc in Geography from University of Rajasthan. Sir is MTech in Remote Sensing from Birla Institute of Technology. Sir has done professional masters in Geovisualization from International Institute for Geoinformation Science and Earth Observations, the Netherlands. He specialized in remote sensing and geographic information system. He was awarded C.V. Raman Fellowship to carry out postdoctoral research work on urban studies from School of Forestry and Environmental Studies, Yale University. Sir has published various research papers in reputed peer-reviewed journals, and he has published books on the marginalization in globalizing Delhi, issues of land, livelihoods, and health and development and disaster management, a study of northeastern states of India. Sir is like Sir was assistant professor in higher education directorate, government of Rajasthan from 1998 to 2002. Then Sir joined as scientist in photogrammetry and remote sensing divisions at IRS Dehradun from 2002 to 2006. Then Sir was adjunct faculty to Center for Space Science and Technology Education in Asia and the Pacific, CSS TEAP, affiliated to UN in Dehradun, India from 2002 to 2006. Sir has been awarded many best paper awards for various research papers. He has been awarded with Raman Fellowship under Indo-US 21st Century Knowledge Initiative for postdoc research work at Yale University in 2013. Sir has been bestowed with state level Shikshak Samman Jaipur 2015. So, sir, thank you very much for accepting our request for delivering the expert lecture. We are very obliged to have you in this advances in applications of remote sensing and GIS. So, thank you very much, sir, for accepting our request. Sir, over to you, sir.
Thank you, Dr. Manoj. So I've been tasked to talk about water resource sustainability today. And before that, I will give you idea that why there is a focus on water resource sustainability. So I will give you some idea about the urban growth. So as you know that there are estimates coming that by 2030, India, will be housing around 600 million inhabitants in urban areas. And by 2050, we will be having 50% of our population. That would be more than 600 million in urban areas. So when such a large number of people will be in an urban area, there will be a lot of pressure on the resources, mainly natural resources. And one of such resource which is essential for our living is water. So I'm going to talk about water resource sustainability. But, to give you idea how big the problem is, we need to have some assessment of current status. So I will take few minutes to give you idea about that. So right now we are around national average as per 2011 census. 2021 census should have happened last year, but because of the pandemic, we are not sure whether Government of India will be able to do it to 2022 as well. Because for that, a complete normalcy is desired. Both state government and central government actively participate in enumeration of our population. So we don't have the latest estimates, but from 2011, we can discuss and we can assess the status of, say, urbanization in India. So nationally, we are 31% urbanized, and different states have different level of urbanization. Some of the southern states, they have a high degree of urbanization, means more than 40%, like Karnataka, Andhra, Kerala, Maharashtra. And in the northern states, which are less than national average, could be like, say, Bihar is the lowest, which is only 11% urbanized, then Uttar Pradesh and Rajasthan. Rajasthan is only 29% urbanized, whereas Haryana, the neighboring state, is a 34% urbanized, which is more than the national average. And if we talk about levels of classification of the towns, then there is a six-fold classification which is there in India in order to understand the urban settlements. So one of the highest classification is the class 1 towns, which are the towns which have population more than 1 lakh. And then the lowest towns, or the sixth, you can say the sixth class is the towns which have population more than, say, 5,000 population. Now this combination of these number of towns across this six-fold classification varies from state to state. Okay. Then fourth important thing is to understand, like, which of the states have large number of class 1 towns. So Maharashtra, West Bengal, Kerala, they are among the top states where there are the highest number of class 1 towns. Now, sixth thing is to understand the processes of urbanization, right? How does the growth take place? So we know that one is a natural growth of a particular city or a particular town. Second, by migration, the people from, you can say, backward regions. I won't say backward states, but backward regions. In search of employment, they migrate from their source districts to the destination districts. Most of them, they migrate in search of employment. So that number, you are well aware that during these COVID times, when migrants, they started moving, they started going back to their homes. So we found it very difficult to get the exact numbers. Reason being, we don't collect in that particular fashion. So their number approximately is around 4 crore. And third, so one is a natural growth, second is migration, and third is reclassification of the settlements, right? So suppose there is a large city, a city grows by its natural growth. That could be because of exogenous and endogenous forces, means interventions which are brought by outside agencies or agencies like, say, central government or international bodies, or some planning, parastatal planning, and then natural growth, that is in situ, that is that comes from within the city, how city works means through the industrial development, through some kind of MSME and all that, right? So this is endogenous and exogenous growth. And if you visualize a particular city, so that is one is a natural growth, second migration, and third is a reclassification of human settlements, which is in the surrounding parts of the city. Suppose there are villages around. Now those villages over a period of time are engulfed or they are covered under the city boundary. It means those villages are turning into urban areas. So that is a village in a next census may be called as a urban area or as a town. And it becomes through a jurisdiction process, it becomes part of the town in say, it's a matter of time, right? So these are three prominent processes of urbanization. And these processes are different in different states. The states like Maharashtra, which is an industrialized state, and so there is a high degree of dependency on surrounding areas. And because of that, there is a resultant phenomena that is called peripheralization. Okay, peripheralization means high degree of growth in the peripheral areas. And this process may not be evident in other states like in Rajasthan or Bihar. Okay. Now, when we talk about these processes of urbanization, I request you to visualize a town or a city, large city. We have 53 million plus cities in the country, which have population more than 10 lakh. Okay. And you imagine, because most of you might be from say, rural areas or urban areas, but definitely since you are attending this particular lecture at NIT Murthal, so you must have done your master's degree from large town, because our education structure is such that in this country, most of the post-graduation institutions are in the large towns, whereas schools and graduation is available in rural area as well as small town as well. But for doing a master's from good institution, students have to go to a large city. So if we visualize the status of resources in the large cities, and particularly when we talk about water, so directly, you will see people, the households in a city, there are many households which are say situated in a informal settlements. Informal settlements means settlements which are squatter, like slum, or which are in unauthorized colony. For them, it's difficult to fetch a potable water, a drinkable water, right? They don't have water within their premises. In most of the slums, for a households of around say 30 or 40 or 50 households, there is a common tap. They have to go to the common tap and collect the water. And the frequency and quality of water may not be as good as those in the formal house. The formal house, like upscale colonies or middle income, high income societies or housing apartments. So when we see a particular city, in a city from remote sensing, we can calculate, we can measure the shape, size, and form of the city, how city is spreading. From remote sensing data, we can find out the built-up, we can find the direction of the city, we can identify the shape of city and with what rate it is increasing, or by what rate it is consuming the agricultural land in order to meet out the urban development requirements. So those things can very easily calculated by remote sensing data sets. And you can identify with higher resolution satellite data, you can identify the location and the places where there is a informal settlement in terms of slum, in terms of unauthorized colonies. So this is limited to satellite data. But how much access a population, a particular household is there to the to water, what is quality of water, what is frequency of water available to those households, how much money are they paying for the water. For that, you need to carry out a detailed field survey. So that cannot be done with the help of remote sensing. It means you need to do a field survey, or you need to then put that information in a GIS, Geographical Information System. And city, you know, as per our 74th Amendment for the governance of the large cities, we have urban local bodies, where the lowest level of governance is a municipal wards. So it means information should be represented at a municipal ward level for some of the parameters which I have just explained to you. Now what I will do is, that is the scenario I'm putting before you. Now, again, regionally, there are three aspects of the water. One is the availability of water. Second is accessibility of water. And third is affordability of water, right? Availability, we can gauge from our remote sensing GIS methods. But before that, we should have a physiographic, information about India. So as you know very well, there are regions like Indo-Gangetic Plain, which is high degree of availability of groundwater. Aquifers are, frequently recharged. Whereas there are regions of arid and semi-arid in the western part of India, and there's a low precipitation, so only 10 centimeter to 80 centimeter of annual precipitation, and there is hardly any perennial river. So recharge is difficult. So there are issues of water scarcity. Okay. Whereas in southern India, as you know, it's a plateau region. So wherever there are valley, there's a good amount of water, but there is also pockets of the regions of water scarcity in different southern states of India. And many of you might have read in the newspapers, or those who have interest in water resource sustainability, Niti Aayog released a report where they have said that most of the blocks, more than 60% of blocks are already in a dark zone. They have overexploited their groundwater, and recharge rate is less than the degree of exploitation. Some of the large metropolitan areas, like which have population around say 50 lakhs, they have overexploited to the degree of 300 to 400 degree, right? So they need to get water from somewhere outside their city region. So one such case study, we are working on mainly 4 cities. We are working on Varanasi, we are working on Delhi, we are working on Gurgaon, Jaipur, and Pune as well, right? So I'm going to present you one of our work that we have done on Jaipur. We are still carrying out. There are not many dimensions to it, right? So I will now take help of slides, and I will give you idea about Jaipur metropolitan region, which is administratively called as JDA region, Jaipur Development Region. Okay. So if you have questions about this scenario of urban growth and requirement of water from the point of view of sustainable development, you can ask me. Manoj ji, you have to give me some time. मैं share करता हूँ slide.
Yes, sir. Yes, sir.
Yeah, sir. Okay, so some of the figures I have, some other part of introduction before we jump to water resource sustainability. By 2050, urban India will be a home of 14% of world's urban population. In less than 30 years, half of India's population will have to cope with urban life, and there will be tremendous
But it's still not shared, I feel.
Hello?
Sir, sharing is not there.
अच्छा, एक सेकेंड. कोई नहीं, अभी थोड़ा रुको, अभी मैं भी करता हूँ ना.
Okay, sir. Okay.
So this I have already told you that by 2050, There will be transformation of land use, economic structure, and social life. And many of you might have heard of, there's a one particular new scale that has been proposed by the scholars, and it is academically recognized, that is called Anthropocene. So within Pleistocene, we are in a age of Anthropocene, where human have mobilized the resources because of their own requirement, and they've altered many natural cycles. Now, in a science, it was published that we have used more concrete and cement than the whole sediments mobilized by the rivers. So you can see amount of alteration that we have brought into the whole ecosystem. So this has led to changes in river courses and flow, depletion in groundwater level, modification of biochemical cycles, and most important is on extinction of many species, mainly amphibian species, and reduction in the biodiversity. Now, in a country like ours and other developing countries in the world, the regions which are suffering through scarcity in terms of water availability, you think of a society which is accessing water there, how unequal distribution of water is there. And this results into changes in the relationships in social power, right? And then there is a socially biased distribution that leads to higher, higher vulnerability. And this is proposed by, one of the renowned scholars who studies political economy, Dog. Okay, so now let me again try. Okay, now it's visible.
Sir, it's visible. Can you do it full screen, sir?
एक मिनट. इसके आगे पीछे बटन ही बहुत है. Okay. Okay, now it's visible.
Sir, it's visible, sir.
So this is so the right hand side is a physical factors, natural resources, which includes air, land, and water. And on the left hand side, socio-economic and political factors, which includes population growth, migration, industrialization, consumerism, communication. They all affect urbanization. The right hand side, what you're seeing is very easily, this is calculated and assisted by geospatial technologies. Now, mostly there are changes in the city. We call that the hardware part of the city. What I have already discussed with you, form, shape, size. And whereas the flow of water and all other commodities, they can only be assessed or by the input of data in GIS format, geographical information, right? So most of our growth in Indian urban cities is unplanned, uncontrolled, and absurd. And whereas ideally it should be, controlled. So, but it's not like that, right? So our cities are not sustainable; they are more vulnerable. Now, this leads to high difference in accessibility, equity, reliability, and sustainability of water resources. Now, these are the four pillars of sustainability: physical sustainability, ecological sustainability, social sustainability, and economic sustainability. In order to get information, to finally get an idea or finally, whether the business as usual is sustainable or not, coming with final decision or judgment, we need to get the information across all these four pillars of sustainability. Now this I've already talked about. I've given you the brief idea. This is like a region. In a particular region supports most of the resources, be it milk, be it horticulture, floriculture, or the provisioning services. Provisioning services includes both food, water, and air. This is all we get supplies from our hinterland, the region which is around the city. Now, those of you who are interested in a regioning planning part of it, then they must refer World Development Report 2009, and where one of the scholars, who's Paul Krugman, he talks about, Paul Krugman is a good scholar for economic geography, and he talks about surplus labor, connectivity, and proximity, which induces more growth in a metropolitan area. Now, this is our study area. The larger region is, you can see in front of you, is the Jaipur district. And then there is a second boundary, that is Jaipur Development Authority. And in between, where the maximum growth is there, that is municipal corporation area, or you can say municipal corporation region boundary. Within the JDA see, there was a shift in the planning. Earlier, up to 1990s, there used to be planning where there were hardly any functional zonal maps. So monitoring was very difficult. And land authority was not having the power to acquire the land for proper urban development. So those legislations were missing prior to, say, 1995. But if you see for the recent plans up to 2031, there are zonal maps and the functional maps which are in place. So this leads to a proper growth, controlled growth. But still, there are questions that we need to discuss in terms of vulnerability, and finally, they are impacting the sustainability aspect in the city. So we are trying to see city through the lens of water, and we are talking about the water resource sustainability. So there are three layers. One is a municipal boundary, second is a regulatory metropolitan boundary, and third is a district boundary. And this district boundary could cut across, a region could cut across different district boundaries as well. Now, if we quickly discuss about the water requirement, so as per the population estimates, there is a requirement of around 700 mld of water in a city per day, right? Out of which 400 mld of water is brought from 110 kilometers south side of the city, right? That is from Bisalpur Dam. And rest of 300 mld water, 200 mld is exploited from the groundwater, and rest 100 mld is supplied by the water tankers. Now this is actually, if you talk about any city, be it Mumbai, be it Gurgaon, be it Delhi, you will find this particular gap in city areas, right? In between demand and supply, and how they are meeting this supply. And because of this gap, we need to also find out which are the regions, which are the areas which are more impacted by this, right? So this is a very important dimension, this existing demand and supply gap, and what is going to happen, say in 2030 or 2050. We need to visualize these scenarios. If suppose business as usual continue to go, then what's going to happen in future? ये कुछ मोटे-मोटे सवाल है. We have to think about that. Okay, so while talking about this, I've shown you this particular map. The water is brought from southern side of the city. Means this district, means the largest area covered is a Jaipur district boundary. On the south side of it, there is a Tonk district, and Bisalpur Dam is situated in a Tonk district. So a energized pumped water supply is provided to Jaipur city, and that is coming from south side of the city, right? Okay, so that is scenario. Also, if you compare, like say, if I talk to you, what is being then done in other cities in the world. So we are through literature and also with our experience, to our mind comes the idea of say western part of America, California district or Arizona state. So there is a हाँ एक सेकंड हाँ जी
Kindly wait for the moment. By the time sir will be back. All the participants who have like registered from different instruments. For example, Redmi is a name which is coming. So I won't be able to mark these attendance. So you all are requested to kindly register from your name. Kindly change your device name or the entry name that you are making bird.
sorry so uh, uh, like in California earlier there was a means they brought water from some river, nearby river from Colorado, and in order to supply water to the city of Los Angeles, they first pumped water on the top of hill. They keep on storing the water, and then from there they started supply of water to the city. So in that order, they consumed a lot of energy to pump the water to high potential, and so it was like energized water, So the cost of the water per liter, the economic value of water has increased a lot. Now, similarly, in this way, we are getting water from the surface water bodies, which are outside the region, larger region, like from the Bisalpur Dam. Similarly, Gurgaon getting its water from, say, Yamuna River. There is a canal called Gadi Harsaru, which brings water to the Gurgaon city. And then that water goes through the treatment plants, and then it is supplied to the cities. To the Gurgaon city. Similarly, you know that there is a Yamuna Vihar, there was a Yamuna Vihar project, and where the water was brought from Tehri Dam for supplying to the Delhi city. So there are many programs like this, and they were commissioned, and crores of rupees were sanctioned in order to supply water to the city. So whether it is a sustainable in a long time and how they are going to sustain. So there is another very good program that is, right now going on under Jal Shakti Ministry, that is Har Ghar Jal. That is also called Jal Jeevan Mission, where government has, promised to provide portable drinking water connection to every household in rural India by 2024. The good thing about the project is this: they also talk about the sustainability of source of water. Suppose they are proposing some particular program or some project for a set of villages. So under that program, they are also supposed to secure the source and ensure the sustainability. So this question of sustainability is being touched upon that particular program. So I consider it's very ambitious program and very important program. Now, many of you who are interested, I recommend you to kindly go to Jal Jeevan Mission initiative website. It is a very good website, and there are some pilot projects. There are some pilot projects which are carried out in rural areas, and how they are using IoT and remote sensing satellite data. That is very well depicted in the website around the pilot projects. Now, second about this year in this 26th January Republic Day, Jal Shakti Ministry Jhanki, the parade. So among the ministries, it was considered as one of the best. So, and I used to actually give the example of that particular initiative to my students in classroom teaching. There is a village called Stock that is in opposite side of Leh town. So this particular parade this year, it has shown that how they are monitoring the mountains for the snow and glacier, and then they are ensuring supply of water in the village, and how they are using SCADA system for distribution of the water in a small village, that is the Stock village, right? Now, but these areas, what we are talking about, like Jaipur city, which has a population of say 2011 population was around 35 lakh, and definitely by this time it must be 45 plus lakh plus population, but official data is not there. So this is demand and supply. Now, these are some clipping from the field. Since there is a scarcity of water and there are pockets, areas where public works department, which is tasked to provide a water to the households, so where they don't have coverage of the supply, they are also mandated to provide by the tanker supply. So most of the tankers, they deviate from their path and they supply elsewhere. So 5,000 liters of small tankers, they charge say around 1,000 to 1,500 rupees, which is a large money for a particular households, and that supply might last for say for a week or two. So it is an extra expenditure on a particular household. So the governance, everyday governance moves around such kind of challenges. And when we are discussing this particular slide, then as we talked about the rural area, there are information which is coming from secondary sources like from census. So census gives information about water, and since questionnaire is along the household, so water available within the household, water is means it's closer to the households, and so there are 5 categories of information related to water is there. So one can use that information to get an idea. Now, but if we generalize this information, then we come to know that even these large cities, the water supply coverage is not more than 60%. Still 40% of the households, they don't have a piped water in their house, right? So this is a large size of population. When there is a say 45 lakh is a total population, and 40% of population don't have a piped water supply in their household, and though it is a basic amenity, for the life, it is essential to have a water. Now then, there are many other questions which comes into our mind. We will be talking about that. So this is like from satellite data from 1975 to 2011. And we are working with some recent data as well. You can see how city is spreading and its distribution across the municipal wards. Now this is the varying population density across the municipal ward. You can very easily say with time there is a compaction and densification in the inner wards, and with time also it is over what you call leapfrogging to the peripheral municipal wards. Okay. So generally we have published couple of papers like on Ghaziabad, on Gurgaon, on Jaipur, where we have used Shannon entropy methods to calculate the urban sprawl, and also a degree of urban growth, how it is varying over a period of time across the municipal wards. Okay, this is for your information. Now, this is the larger picture about the city. Before independence, or when state was a Rajputana state during British times, Ramgarh Lake was constructed in the eastern side of the city, and walled city used to get water supply from Ramgarh Lake. And you might remember that in 1985 Asiad Games, the water games were organized in Ramgarh Lake. But by 1990, because of population growth, there was excessive pressure on the surface water. And that time we were doing our graduation and post-graduation from the city. And I remember that in a normal year after rainfall, we used to go Ramgarh Lake, and we that time we could see some water. But after say 2000, there's hardly any surface water left in Ramgarh Lake, right? And during that time, realizing pressure on that particular water resource, Bisalpur Dam was commissioned. Then Bisalpur started supplying water to Jaipur from 2009 onwards. In 2005, the JDA commissioner, he in an open platform, he said that city will face very difficult times in years to come, and there might be rationing of water will be done, right? So that was kind of scaremongering that was going in between, say, after 2000, or you can say 2000 to for 10 years, that kind of scaring was there. So in 2009, this Bisalpur Dam was commissioned and water was brought to the city. Now, as I discussed about the current scenario, so we are somewhere in 2021. Okay, so as I said, in 2021 there is a demand of 700 MLD. 400 MLD is being supplied by the Bisalpur Dam. 200 MLD water is we are extracting from the ground, and around 100 MLD is being supplied by the private tankers. Okay, so this is the scenario of the surface water, what you are seeing in this particular slide. Now, the business as usual, if continues, and the catchment area of Bisalpur Dam is mainly from southwestern districts of Rajasthan. And there are other urban areas which are also demanding share of water from Bisalpur Dam. So how much Bisalpur Dam can augment, means how much they can give more than 400 MLD, that is the question. And if suppose there is consecutively, if there are drought years, 2-year drought, 3-year drought, 4-year drought, what would be the situation in the city? How question of sustainability will be addressed then? And with rising temperature and climate change, that might result into the conflict in the catchment area of Bisalpur Dam, how it's going to impact the storage capacity of Bisalpur. So these are some very pertinent and pertinent questions that one has to study and introspect. Now, if business as usual continues, so whether it's going to be sustainable or not. So that is a big question. So we will again discuss these particular points in the next slides. This kind of information, what is given before you is like location of drinking water sources. This is from Census of India. And a similar kind of information is also provided, but with the with say income distribution across the class category, socio-economic caste category like ST, SC, and OBC households, how they are accessing the drinking water that is generated from NSSO data sets, right? Now, this is in a GIS environment. These slides, what you see in front of you are in a GIS environment. So you know that Central Groundwater Board, CGWB, and State Groundwater Board, there are two different nature of wells which are there in study area. They make observation like state groundwater board through the help of district chemist. They measure pre and post monsoon depth of water, and along with that also quality of water. Quality, they take measurements for quality of water, right? Similarly, central government wells which are monitored by CGWB, they also monitor their wells, and they have installed piezometers in order to monitor the groundwater. So this is information from 1991 to say we have information up to 2020, right? So one can find out the status of groundwater. So groundwater has depleted, say, more than 15 meters. And as you know very well, it also depends upon the geomorphology and geology of the region. The alluvial plain area, pediment areas, or which have a geologically hard rocks. So it depends upon the geomorphology and also the nature of aquifers. But most of the aquifers are, are overexploited, and the rate of recharge is very less. And through this mapping process of say around 300 wells, which includes state monitored wells and central government monitored wells, one can find out pockets where there is a higher degree of groundwater exploitation or say depletion. Some of the wells are completely depleted. So with time, you can see like in 2010, the walls which were there in the central part of city, right? Like say from Sodala or civil lines, water used to be supplied to the walled city. So now those wells have completely dried up. Now they are fetching water from the southern side or the western side of the city. They have gone beyond the Bambala Bridge. They're on the Tonk Road after Sitapura industrial area. They've gone beyond that, and they are, drilling deep wells and fetching water and supplying to the city. I'm talking about 200 MLD. So this maps talks about 200 MLD of water, and this is one of the most, groundwater is highly overexploited. Not yearly replenished, recharged aquifers. Now, in such areas, such pockets, which are not under, say, Bisalpur drinking water supply coverage area, and they are depending on, say, only groundwater. You think of those areas. So one, you think in terms of a geographical area. Second, you think in terms of locality where human beings are living. Then you should also think in terms of economic strata. Economic strata, the households which are well off, the households which are poor. So think of condition of poor households, how much money they have to spend for getting this drinkable water. So everyday life is not that easy. The poor households means the households, if you categorize the households which have income less than 20,000 rupees per month, or households which have income less than 10,000 rupees per month. So how much their family members are spending time to fetch water? Suppose there is a girl in a household. As you know, ours is a patriarchal society. We are highly discriminatory against towards the girls. So the girl kid, they have to walk outside house, they have to get water on their head. That time they could have used for any other say productive activity, maybe for say studies or for pursuing some other economic activity that would have been more beneficial. So that kind of information one can bring through say ground surveys. So this particular slide I told you to, you just visualize geographical setup, then locality setup, then setup across the strata of society, and think not about surface water, because not each and every geographical area or location of the city is under the service area of say Bisalpur water, right? So like in peripheral wards, the this Bisalpur water is not available, right? It is. So what could be the situation? And even within the city also, there could be area within the service area where there is not good frequency of water, right? Means if water is coming, it is coming early in the morning, somewhere say 4 a.m., 5 a.m., and it is coming for 10 minutes. And that water is not sufficient for a size of the household. And that depends upon many other social things that we have just discussed. So this is across, we retabulated this information across the municipal ward, because we also had, other information that is coming from satellite data about urban growth. The scale of measurement is a municipal ward. Now this is, we have already discussed this particular slide, and this also we have discussed. Okay. So this is showing that how recharge is depending on both urban growth, and water is depleting with a high rate, and there is a less water recharge. So this is the message from these slides, right? These are some stories that that are published in a newspapers or media. Now, this is information in terms of accessibility that was calculated or finally tabulated as a index from the survey, right? So like for accessibility percentage of household having supplied of piped water, households having more than 75 liters of water consumption per person per day, right? Per capita, PCPD, per capita per day. Percentage of household having water source within the premises, percentage of households pay water bill more than 10 rupees a month, percentage of household getting water more than per hour per day. Now, after giving a ranking to this, the ward-wise index is calculated. You can see that the value of accessibility is very less, especially in the access is less in peripheral ward, and also there are exceptions which are closer to the core of the city. Now, these are very important statements because they reflect the reality. Now, in this particular picture, you can see this is one particular, bilanes, and you can see number of pipes coming out of it, right? So there is no connection in the home. There are few nalas for entire street, nulls. And there is also not a fixed time for water, but generally water comes around, say, early in the morning. So that is a big, problems. And then they have to collect the water at that particular time. And then throughout day, there is hardly any water. So PhD and Public Works Department are responsible to provide Public Health Department and PWD. PWD does the engineering work, and PhD take care of the supply and other management aspects. So when, as a scholar, if you go and talk to the official, they will say, okay, everything fine, we are trying our best, and most of the area is well serviced, right? But on the ground, we need to engage, we need to use both remote sensing and GIS approaches and get information filled into GIS system, right? Because most of the time we finally end up doing remote sensing work, but we forget to bring this social realities, social and economic realities into GIS framework. Now, this is the frequency of water supply. Again, this is information is captured through survey. Percentage of household with functional water meter, percentage of household without any grievances with water supply. So these are, say, about 9 indicators. Now, some of very important one, like percentage of household reported no water supply less than 5 days in a month. Percentage of household reported poor water supply less than 5 days in a month. Right now, we don't also have the awareness about the water quality, right? So how do we come to these kind of points? Like, say, NSSO is one of the agency which collects the data. And NSSO says that, 85% of the population, 85% of the population is satisfied with the quality of water. And similarly, there is a similar number, maybe, they're slightly 2% more. They also say that the urban inhabitants or rural population is also satisfied with the supply of water, drinking with the quality of water. Now, on the ground, if you do the survey, you will find highly mismatched, highly mismatched what is being reported in other sources of information that is coming. Just a minute, please. देखना पड़ेगा ये, इनको वापस कर देंगे ये पैसा, अपने पास रखने का क्या मतलब इस पैसे का? ठीक है, मैं अभी क्लास के बाद बात करता हूँ। अच्छा, एक लड़की है पायल बोडिया।
Sir, it seems you forgot to unmute. Yes, sir. Yes.
आपने लेक्चर ऐसे टाइम रखा है कि ऑफिस लंच के लिए बंद होता है उस समय ना?
Yes, sir. Yes, sir. Yes.
तो बहुत सारे कागज वागज भी आते हैं।
Yes, sir.
ओके, कहाँ थे अपन? So I think you get a fair idea about this, and then this is the overall vulnerability that is calculated from the survey. So it is again consisting of around 8 variables. Percentage of household having shortage more than 25 liters a day. अब इसमें अलग-अलग हैं, इंटरनेशनल जो मापदंड है, द गाइडलाइंस है, ग्रेया गाइडलाइंस है, वो कहते हैं एक व्यक्ति को 160 लीटर वाटर पर कैपिटा पर डे, 160 लीटर वाटर मिलना चाहिए, और हमारे यहाँ पे 25 लीटर भी नहीं है ना कुछ एरियाज के अंदर, और कहीं तो पूरे हाउस होल्ड के लिए ही 25 लीटर है। तो आप सोचिए, हालात सोचिए। Percentage of households having water shortage more than 4 days in a month. Percentage of households manage water shortage by calling a water tanker. Percentage of household grade water quality as poor. Percentage of households get water quality less than 5 days in a month. So I think so by this one can map those areas and represent across municipal wards. Okay, so this is the regression we have done. So this is the private players. Mainly in these areas, they are providing the water, and the cost of water from private players is very high. The monthly budget get enhanced, you know, और गरीब परिवारों के लिए बहुत मुश्किल हो जाता है फिर ये. Now this slide, like an overall perspective of water sustainability, we have already discussed. This is much more important. Like we talked about the sustainability concept, and in a social aspects of sustainability, we talk about inequality, unavailability, unreliability, inclusivity, uneven distribution that is captured on GIS environment, then ecological thing like hazard growth, increase of pressure on Bisalpur, and also groundwater depletion. Economic is
Sir, your voice.
hello.
Sir, your voice is coming very.
Over exploitation of groundwater. Hello.
Sir, now it's coming, sir.
बीच में चली जाती है ना, थक जाते हैं.
हाँ जी सर, हाँ जी सर.
Over exploitation of groundwater. Now the business as usual. How this business as usual? What will it lead to? Will it lead to a unsustainable development, right? And how you can reverse it? ये एक discussion का part है. But here now as a solution, there are many solutions available, like water harvesting is one traditional method. Second, like in a city like Jaipur, 400 mld of water is being pumped. So that water is end of the day is going somewhere, right? It is going in sewage. So how that water can be reused? So there are a lot of technologies which are coming in reuse of water. Some of the methods which are readily applied, like through STP, sewage treatment plants, and that water could be used for other purposes other than drinking. And there are also like what we call how to manage the gray water. So gray water is of different type. The water that is coming from kitchen and say bathroom, right? So that can be used and that can be recycled easily. Whereas the sewage water has to go through STP and some other treatments, then finally it can be used. So now the main focus is on reusable, right? To how to reuse water. In some of the countries, there are two piped water system. Like I was talking to you about Los Angeles. In Los Angeles, I visited the city. So in a hotel, for a bathing purpose, when you switch on the tap, you will get some kind of brownish water, right? So for bathing and other purposes, they make use of recyclable water or reused water, whereas for drinking purpose, they use the fresh water. So these kind of things, technologies and methods need to be adopted in order to address the questions of sustainability. Otherwise, it will be very difficult. The business as usual is not sustainable, right? And our household expenditure is increasing. Now you have meters in households. If you consume much more than a particular amount of water, then you have to pay more. And the areas, the new colonies which are coming, high-rise buildings, to them, surface water is not provided by the state. And they have to depend on their own water source. For that, they get water through tankers. So again, household expenditure is highly increased. So these are some of the questions we have to pitch in, and we have to find out the solution. How what are the affordable solutions which are available to us? Okay, so thank you. With this, if you have questions, you can ask me, right? Hello.
Yes, sir.
If there are some questions, you can.
Sir, they are not the questions. They were typing their attendance mostly.
अच्छा. अब इसमें कुछ GIS के लिए, जैसे मनोज कहते हैं सर थोड़ा GIS में बताओ. So we have generated, like in a GIS environment, I have shown you for the urban growth and for dependency, one can find out with the rate of growth from built up data that is extracted from satellite data. And also from depiction of settlements and villages, one can find out which villages one sees, decreasing percentage of cultivators and increase in the female literacy. So these are few variables which indicate towards the development. Apart from that, I have shown you slides like Central Groundwater Board information and State Ground Board information that we get from these departments. This can be fetched into GIS as a point data, and then one can interpolate and do some kind of modeling. Now, underground water modeling is one of the toughest areas in GIS because a lot of information is required, like type of aquifer, depth of aquifer, location of aquifers, and also we need a geomorphology, very detailed geomorphology map of the area, right? So these are the things that help you, mainly these three things: groundwater wells information, pre and post monsoon, along with precipitation, second, location and type of aquifer, and third, geomorphology. So these all fit into GIS environment, and then one can do modeling to find the most vulnerable geographical areas, groundwater potential areas, right? And then I think you can, by a block wise, one can show the amount of water depth or the depleted water in terms of depth. जैसे पहले पानी 40 मीटर पे मिलता था, आज पानी आपको 70 मीटर पे मिलता है, right? So in some of these pockets, if you go, 280 फीट तक पानी नहीं है, 280 फीट तक पानी नहीं है, फिर आपको एक हार्ड रॉक मिलेगी, सेमी परमिएबल रॉक मिलेगी, फिर एक थोड़ा सा लेट के बाद में थोड़ा पानी आपको मिलता है, and that is in a small quantity, and then there is hardly any water left. So most of these wells have completely dried up in many parts of, like some of the pockets, that areas which I have discussed with you, 5-6 cities on which we are working. 3 cities we have enough good amount of data on, and then we are trying to gather more data about remaining cities. So yeah, so one should remote sensing data, GIS data, and then third also, we emphasize you and we encourage you to try to get the socio-economic, data through your field surveys and try to see overall sustainability. क्योंकि end of the day technology, कोई भी technology है, remote sensing, GIS भी technology है, and ये जो मानव विकास है, the quality of life है, तो किसी भी technology का use human development के ही काम में आता है. It is not for the doing for the sake of technology, है ना? अगर हम घर में सुई धागा के बाद में मशीन आई, तो उस टेक्नोलॉजी ने हमारी जीवन में सुगमता लाई. ऐसे ही अब हमें कोई दवाई चाहिए, कोई बीमार है, तो उससे हमारी क्वालिटी ऑफ लाइफ, मेडिकल हेल्थ सर्विसेज से हमारी क्वालिटी ऑफ लाइफ अच्छी होती है. तो ऐसे ही रिमोट सेंसिंग GIS हमें ये चाहिए कि कैसे हम रिमोट सेंसिंग GIS को यूज करके कैसे हम हमारी जो आपकी मार्जिनलाइज कम्युनिटीज हैं, या जो ऐसे लोग हैं जो मुसीबत में हैं, गरीब हैं, कैसे उनकी जिंदगी के अंदर हम तब्दीली ला सकते हैं. पॉलिसी को कैसे इम्पैक्ट करें. जब तक पॉलिसी को इम्पैक्ट नहीं करोगे तो वेयर विल आवर रिसर्च विल लीड टू. सो ये बात है. सो जब मनोज जी ने बताया, पहले आई वाज साइंटिस्ट इन इसरो. सो इन इसरो वी यूज्ड टू डू मोस्टली technical things like accuracy, classification, right? And different nature of data sets, how to make use of that. But अब जैसे JNU में आए, सोशल साइंस में के स्कूल में आए, अब ये हुआ जो कुछ भी कर रहे हो उसको पॉलिसी में लेके जाना है. तो आजकल हमारा फोकस यही है, कोई भी रिमोट सेंसिंग GIS का एप्लीकेशन है, which ministry it is going to inflect and which are the areas in which we can engage ourselves and we can make a difference, especially for the marginalized communities. अब आपका कुछ सवाल है तो आप पूछिए. Okay, so there are few questions I can see, like RSGIS 115 NRG asking how many observation points required. See, more are the points, better would be the quality of output, right? Right. So that is there is no standard thumb rule कि कितने points को requirement होगा, right? So geographical area पे minimum कितने होंगे ये आप पूछ सकते हैं. तो minimum तो वही statistical method है, it should be representative. And what are the important groundwater parameter to be considered? So for water depletion, we are more concerned about the what we call BGL, below ground level. Below ground level आपका कितना meters में BGL in meters. बिलो ग्राउंड लेवल कितने मीटर आपका पानी नीचे गया है, यानी डिप्लीट हुआ है. हमको ज्यादा इंपॉर्टेंट वो चाहिए, क्योंकि क्वालिटी अभी फोकस नहीं है. क्वालिटी भी अगर किसी को इंफॉर्मेशन चाहिए तो वो चीफ केमिस्ट उनका क्लोराइड, फ्लोराइड, TDS, pH, all that kind of information is also available. But right now we are talking about here quantity, not the quality. ओके, फिर ग्राउंड वाटर पैरामीटर. जैसे अगर आपको ग्राउंड वाटर मॉडलिंग करना है तो मैंने आपको बताया कि पीजोमीटर और वेल्स की लोकेशन के अलावा हमारे पास एक्वीफर का टाइप क्या है, एक्वीफर की लोकेशन क्या है, ये होनी चाहिए. जियोमॉर्फोलॉजी, हाई क्वालिटी जियोमॉर्फोलॉजी मैप होना चाहिए रास्टर डेटा में. फिर आप उन तीनों को कोरिलेट करेंगे, क्योंकि रेट ऑफ डिप्लीशन ऑफ वाटर इज हाईली डिपेंडिंग अपॉन जियोलॉजी एंड जियोमॉर्फोलॉजी ऑफ द एरिया, प्लस द प्रेसिपिटेशन amount of rainfall that is being received. Then Deepa continues to talk, can we allow rainwater into unused bore wells? Yes, very good idea. Unused bore wells में ये भी एक बहुत अच्छा मेथड है कि उसमें फिल्ट्रेशन अगर आपका अच्छा है तो डेफिनेटली इट हेल्प्स टू रिचार्ज द वाटर. और ये मैं रिकमेंड करूंगा दीपा जी कि आप जल जीवन मिशन की वेबसाइट पे जाएं और वहां पे कुछ और भी मेथड दिए हुए हैं जो हमारे गांव और शहरों के लिए काफी यूजफुल है, तो आप उस पे जाके देखें. तो ये कुछ सवाल थे, और कोई सवाल इसमें है नहीं. ठीक है मनोज जी.
Thank you very much, sir. Thank you very much for finding time and providing us some important information related to the basic like population projections and how it is directly related to the sustainable water resource management. So thank you very much, sir. Thank you very much. We'll love to see you again on 14th Monday.
आपका कोई सवाल है? आपके पार्टिसिपेंट तो नहीं पूछ रहे?
Sir, participants are, it seems like we discussed na, these online things are.
हाँ, ऑनलाइन में हमें भी मजा नहीं आता, क्या करें?
हाँ. Sir, the courses are planned in the physical mode.
नहीं, आप अब धीरे धीरे खोलो. JNU में भी हम लोग अब कोशिश कर रहे हैं.
सर यहाँ पे भी खुल गए हैं अब.
हम भी 1-2 महीने में पूरा खुल जाएंगे.
हाँ जी सर. सर हमारे यहाँ पे we are having the Shuttle Academy also with us now. So we'll be regularly organizing these programs along with the like physical workshops. So we'll be inviting you very soon. From March onwards. So, and because this Atal Academy director is very close to me, so I'm hoping at least 2 programs he'll give it to me.
Okay, so, good.
Sir, see you on Monday 14th.
Okay.
Again, same time.
Okay.
Thank you very much, sir.
Okay. Thank you, Manoj.
Thank you, sir.
Okay.
To all the participants, I request you all again to kindly clarify your doubts, fall in discussion with the experts. So that will lead to like generate interest in the FDP and will be like able to assess that will be at the time of making reports to AICT Atal. We also have to mention these kind of details, that how many participants asked question and what type of engagements these discussions were there or not. So I request you all to kindly engage in discussion with the experts. So we'll be meeting you again at 2:30 with Professor Poonam Sharma as our expert speaker. She is from Center for Disaster Management Studies, Shahid Bhagat Singh College, University of Delhi. She is director there, and she'll be speaking on application of geospatial technology in measuring and impact of built up areas on the environmental sustainabilities in urban areas. So I request you all to kindly get back in the meeting room at 2:20, by the time 2:20, so that we can start the session well in time. She is very pertinent to time, and she'll be joining by 2:25, and she'll start the session at 2:30. So I request you all. So thank you very much for attending and being patient listener to the second session. Thank you very much.